All right, so this is what we got. This is awesome. It's such a little amount of resource, and it's just great. So we got about a 3-inch rotor with 6 magnets on it, which is actually 18 magnets, but there's like 3 in each one of these holes, so it makes 6 magnets basically. Um, the coils are hooked in series. I'm just doing a quick live stream to show this off before I go to the gym, and then I'll be back after that. And I got an axial-flux gyroscope that's underway. It's going to be pretty cool. All right, so this is 3.5 volts and about 200 milliamps. Might get down to 100 milliamps. We'll see what happens. $991 at 3 volts, 3.5 volts. Oh, 100 milliamps. So like the faster it goes, the more amps will drop off. We got 1,037, 1,038. Let's turn it up to 5. So 5 volts, 0.3 amps, 300 milliamps. That's awesome. This is awesome. 1,400. You got a nice air gap there too. So in order for me to close that gap, I usually use these. This is what I started off with. And you just plop these on there, but you can't have it going real fast with these just plopped on there, so I took them off. And it works. It works and it draws less amperage. Might be a little off with this one, might be like a millimeter farther back than the other two. Kind of hear it rumbling. .1 volts in and 0.6 amps. Man, this little devil is moving. 16, oh, 1684. Wow. 1720. 1737. 1750. 1760. 1762. $17.70. I think it runs a little bit smoother, having a little bit of an air gap there. You can kind of get a feel for how far the electromagnetic field extends. This is really exciting for me because I never got anything to get above 1600, 1700 RPMs. Looks like we're well on our way to doing that right now. Hello everybody, welcome. Turning it up to 9 volts, 0.8 amps, 1954. $2,000. Woo! $227. Wow, that is just so cool. All right, so it's the 3 coils in series. I got and it's on a transistor, just a standard connection, base, collector, emitter. I got the reed switch hooked up to the base, drawing power from the collector. So it's hooked up directly to the transistor, and we get really good feedback with that. $20.77. It's 4 inches of iron at a 1/2 inch diameter, wrapped 2 layers of 20 gauge. I didn't count the turns. I just know that it's 2 layers. So one up and one back for both of them. I did it counterclockwise. I'm pretty sure that if I just wiggled it around a little bit, I could be going clockwise like immediately, but I know you're not supposed to do that. Just keep it the way you started, and then it should point north every time. If you just keep everything the way it was when you started winding. But I got into I'm winding clockwise now, and I'm like, how did this happen? And I flipped it like this. But yeah, it's all counterclockwise. 20 gauge, 2 layers. I didn't even know you could get a pulse like this with such a little amount of material. That's awesome. I think using that reed switch has something to do with it. I'm going to go up to 10 volts. $21.64, $21.81, $21.91, $22.01. Nice. 2200 RPMs, ladies and gentlemen. Woo! So, with that being said, this is the series circuit, and I know that if I hook these up with each having their own transistor and their own power supply, because I can do that now. Cool. they could go by the same switch, just one reed switch, to fire all three. It's the only way to do it. I'm pretty sure there's like maybe a spot on there. Well, I don't know. I mean, maybe you could do it the other way, but I just having a reed switch for each coil seems to be kind of like maybe a hassle considering how they work. But I don't know. I really don't know. All I know is that I like hooking them all up with the one switch so that they all fire at the same time, guaranteed. Just my preference. And we're gonna hook it up parallel, and we're gonna do, I don't know how to do a torque test really, but we're gonna see the difference in how they run. I'm pretty sure that with a parallel circuit and this little material, we could get going at like 0.5 of a volt and start drawing like some heavy amps at that point. I'm using tip 142s in this package, so they're bigger, but they are tip 142s. They don't handle surges very well, and you need resistors if you're going to be doing surges. And then I got 147s, but I don't know if that'll work with this. That's the PNP complementary of the tip 142 NPN. I don't know about PNPs. I haven't used them successfully yet. And I always, the NPNs are like the way to go. The PNPs, I don't know. I heard they were pretty good. I just don't really know how to use them. And these are medium switch pace. You know, these are medium switching Darlington transistors. So that's pretty cool. I wonder what a fast switching transistor would do. That would be pretty sweet. Find that out. And it's like my buddy sent me a video of a high torque pulse motor, and I looked at the coils and I'm like, wow, I can do that, you know. And then I'm like, well, my rotor has 6 magnets on it, so I'm going to do a 120 degree. And I had 3 pieces. It was like, wow, this is just meant to be. It was meant to be. But that's cool. 2200. Let me shift the focus for a second here. Yeah, sorry I'm not responding. Like I can't. I don't have a visual of what's going on in the chat. But this, excuse me, is an axial flux, or it's going to be an axial flux gyroscopic pulse motor. See, so this will go this way and this will go this way, like so. You can hook it up horizontally. But let's do this. Okay, now the transistor and the reed switch are hooked up to the one in the middle. switch the coil, right? Okay, so we got a little coil right here. I'm probably gonna, upgrade this a little bit. And probably make this rotor a little different. It's just conceptual right now. But it needs a commutator and a few other things. But anyway, we got this coil right here. And this should work if everything's going like according to. And then we got our 3 magnet, and I have more of these ferrite blocks that we can do. Like, these are all north facing out. We can do south facing out, or we could leave it the way it is. If I'm going to use a reed switch though, I want to leave it the way it is. Now it's tethered right now. It doesn't have its commutator, so it's not going to gyro. But the axial flux, it'll work. As soon as it's free to spin, it'll work. Because the actual gyro effect, or this spins this way and this spins this way, happens naturally when you get the two together. And they're both free to spin. They will spin in opposite directions, because that's what pushing off one another does. And that's really what's going on. And it's so cool because once it gets timed and everything, it's going to increase in speed, or it should every time. At least up until the potential. When it's gyroing, I mean, when it's going both ways. I think it's just neat. It's really cool. I can kind of smell something. Yeah, I think when I put it over in front of that other let's just try this. Five volts in. Hello everybody, I'm not neglecting you on purpose. I can't see what's going on right now. So that's one coil on stator. I thought it was a nifty little design. I kind of made it the bobbin a little bit smaller than the block, and then I wrapped it oversized coil so it would be about the size of the block. And it works really, really, really good. And I think the reed switch and like the way I have it triggering the transistor is really what's making it work. Thank you, 007. Currently, I am not generating any electricity. I don't have any multimeters hooked up. This is just a pulse motor, fun, free for all. I like the fact that I got it going 2200 RPMs, 2210, I think. I got a bunch of new projects on the board here. All of these can generate electricity. I just don't have them doing that right now. I think that's a nifty little design right there. Can't go wrong with that. I didn't think these coils would work, but they're working like better than anything that I've got going anywhere else. I'm gonna remove the shaft and the rotor here. I'm gonna get my Neo ball, put it in like a pill bottle or something. Put it in something you can see through, like that, and put it in the middle here and see if we can't get it to spin. Sound like something we can do when I get back from the gym? Sound like something we can do later? I think that'll be sweet. I don't have any idea whether or not it'll work, but I think those magnetic fields might actually hit the ball in the middle there. I think they touch the pole right now, I think. So they radiate at least this far. I might be wrong about that. Might be totally wrong about that, but I think the electromagnetic field extends at least to the pole from all three of the magnets. But we'll see what's up. In other words, it's a strong magnetic field. And it has fewer turns. Actually, I don't know how many turns are on here. I just know that each coil has 2 layers of 20 gauge, and they're 14 inches, 4 inches long, and a ½ inch in diameter. So with those numbers, maybe you can figure it out. How many turns? I don't think it's tremendously important to know that when you know all that other stuff. I'm pretty sure, like, making an equation out of some of that data, you'd be able to figure it out. How many turns? Oh, all you need is the diameter of the wire, and then you're good. And I think it's 0.0315. like it, man. It's so easy. It's so smooth. And then with the reed switch backed out that far, we're drawing virtually less than 100 milliamps right now at 4 volts. All right, so let's turn it up a little bit. So we're going to go in 9 volts and we'll let it settle. .8 amps. So 9 volts, 0.8 amps. Let's move it in now. 1.6. 1.5. 1.4. Wonder how much speed we'll get out of this. It went from like 1500 to 1600 in like less than a second. Heck yeah, we're above 2000 right now. 2225. Oh wait a minute, no, 20. Yeah, 2216. Okay. $2,400. Oh yeah. So neat, man. So neat. There we go, right there. Almost 2,500 RPMs. So we're gonna like try to get up to 5,000 sometime here. We're gonna have a rotor design that'll safely house the magnets to go at a speed of that nature. We're halfway there. We're halfway there. And there's a torque model. This is not the torque model. It's connected a little differently. It looks the same, but there's 2 more transistors and 2 more power supplies. And You know, I could hook it all up through power distribution and just hook it up to my power supply, but I've been doing that the whole time, and I think I'm going to use some of my 12-volt batteries. Batteries, you know, clean, cut, and dry, and what is it? So each one of these coils isolate and pump in with the same amount of power. All right. I really want to do this, get this gyroscope done, the axial flux gyro. That, I think that one will be sweet, like really cool. And you can power it in different ways, especially if I leave the turbine part of that on there. You could just turn on, you know, your shop vac in reverse, put some air on it, fire it up that way. You know, but it'll move like a standard pulse motor, and then it'll gyro. All right, so this is the shaft, and it's fixed to the stator. Normally it's the other way around, so this is totally different. And I did it this way because the pieces presented themselves to me. It wasn't the other way around. So you got those two bearings on there, so this will spin relatively smoothly. Probably gonna need to loosen it up a little bit. Maybe even put it on a maglev. But anyway, that shaft will spin like so. It's gonna need probably a few more coils. I'm thinking maybe even just 4 altogether. Probably take that one off and get them positioned correctly. And there's two bearings right here, and it keeps the separation within half a centimeter or less from the coil to the bottom of the rotor. And that core is printed iron infused PLA. Works pretty good. I mean, it's pretty magnetic. 45% iron powder. And then, of course, the other one, iron rods, soft iron rods. So I kind of want to see the parallel hookup of this pulse motor. but it's, let's see here. I mean, you can't really see it. It's not because it's small. It's because it's like translucent. You can kind of see it, but it's like, yeah, I don't know. Can't really even tell if these are good or not. They look like I've used them already. Yep, this is a 142. Man. Yeah, aside from doing that right now, I need to get that magnet off of there. I'm lucky that happened. Yeah. Okay, now I need my little wrench. That's right, my little wrench. I heard somebody ragging on my wrench the other night. I hate it too, man. It's so small. Anyway, we're getting a neosphere hooked up here. Okay. So I think pretty precise placing is going to be required here. I need my stand. Here we go. I'm gonna have to transfer these. All right, I might not be able to just sit it there. I might have to hold this thing. Woo! Man, this probably won't work. Not without stability. Let's try the ball and the stand. Well, it's interesting. Maybe it's not low enough. But I think it's in the right spot. It looks good to me. Maybe it's too far away. Well, I got an idea. I have a great idea, actually. Use a signal generator. Probably should have thought of that to begin with. All right. So we're going to send a pulse to base, and hopefully we get some reaction. We're going to start at a really low frequency, like 6 hertz or 7 hertz. Oh, I hear it. It's working. Look at that. It's working. Maybe if the coils were at 180, because they're definitely affecting this ball for sure from where they're at. Let's turn it up one. Let's try removing the stand. I'm just holding it there. Whew. Wow. All right, so holding it there is probably not going to work. about this one? Like this. No. I think this is the best positioning in this tall one. Like slightly above the coils, because I think it's going like this. Magnetic field. Anyway, and the magnetic field is definitely touching the ball in the center, as you can tell. It's just 3 volts. Let's mess around with the try 12. Maybe I'm thinking the series circuit isn't helping, but we'll see. And then maybe an air coil. Instead of the really strong cores, just plop it right on top. I think it's cool though. I mean, it's definitely working there. So 5. We'll do 5 in. We'll slow down the frequency. Oh, I can feel that. Holy smoke. Alright, so I got a plan here that doesn't involve this particular setup for the Neo ball. And it's covered in ferrofluid and graphite powder. get a different angle. But I mean, I was really just trying to see if the magnetic field from those coils was reaching the center. And it is. So is, man. It's far reaching. Oh. It's alright. I'll either have to put that back on here or I can do it this way. We'll see if I can get the same amount of speed this way. It's a little high. So welcome everybody. I apologize for not being engaged. I am just doing this and showing you guys what I'm doing step by step. This is a 120-degree 6-magnet rotor pulse motor. These are electromagnetic coils at 120 degrees. We have to do an oscilloscope test. Find out what the frequency is. And then we can plug the frequency into the signal generator and just run it off of that. And then so what I do is I take the brown wire or the input, the one side, whatever you want to call it, and I hook that up to the collector. And then I hook the output of the reed switch up to the base. So the blue wire goes to the base. You just want to have some sort of, and you recycle the power that goes through the reed switch because it's hooked up to the collector. And it flows through. I don't know, at least I think it's significant. I might even be able to hook it up to the emitter and have it dumped directly into the ground. So that's what it does. I don't have any generator capabilities hooked up to it right now. All these are single strand coils. um, that are solely for drive purposes. There's no bifilar things going on, so I just didn't see a purpose to do any SG or anything like that, considering they're all single file coils. I just hooked the reed switch up to the transistor, hooked the transistor up to the coils, and grounded everything, and it works pretty well. Now these coils are in series. I don't know exactly how many turns, but I know that each coil has 2 layers. If I were to guess, I'd say each coil is roughly 100 turns. Roughly. Probably more like 60 turns. The core is a soft iron rod that is 4 inches long and I think here 1/2 inch in diameter. So there's a lot of flux going on here. And if you look at this thing from the top, it looks pretty sweet. Hey Peter, what's up, man? I'm glad you can make it. I don't know how long you've been here, but it's good to see you. What's up? From Detroit. Yeah. All right. So this is totally controlled by how much voltage I put into it. So we'll go up to 5 volts, 0.6 amps. Now if I want to draw back, stop pulling so many amps, just pull this straight back. Not too far though. Now I'm drawing 0.2 amps. And we're still moving quite a pace. Ten volts. 1 amp. So 10 watts, 9 watts, 2042 RPM, 2050. $2,074. Oh, we broke. I had a barrier of like 1,700. Let's see what time it is. Oh, I'm gonna be going to the gym pretty soon, but I'll be back. I will definitely be back later on this evening. $12 volts, 1.2 amps. $2,300. 2383. Oh. $2,393. 2,400. And my rod is here. I gotta wash my hands. Got graphite powder and ferro fluid all over them. That is a nifty little contraption there.
What's up?
What's up? All right, so with that, thank you very much, ladies and gentlemen. Peace out. Have a great day. I'll be back this evening, and we'll hook this up in parallel when I come back. Thank you very much. Bye now.